Again. Alright, so we're solving exponential equations. In these problems, to solve it, we're going to make the bases the same first. Once the bases are the same, we're going to ignore the bases and set the exponents equal to each other. And then just solve it like normal. So in example 1a, the bases are already the same, so we're only looking at the exponents. Now solve for x. So get rid of the minus 2 by adding 2. So it's negative 2x equals 4. Divide by the coefficient of x, and we get x equals negative 2. Final answer.
That's it?
That's it.
Awesome.
For now.
Yes, it does get worse. G. Well,
Tomorrow.
they get progressively worse.
Is tomorrow a review sheet?
Tomorrow's a review sheet.
No,
Or
this.
this whole month?
No, review sheets always have everything, including what's on the quiz.
No, I mean it's only this. Like,
I just told you, it's everything, including what's on the quiz. It's only 6 problems, though. I mean, how many ways can I ask the question? Well, it's 10 problems. But the review sheet only has 6. All right, here we go. So, here we go. 9 is not the same as 3. But can I write 9 with a base of 3 and an exponent? 3 squared. Very good. So it's 3 squared. So it's 3 to the 3a plus 1 equals 3 to the second power. Okay, now that they're the same base, we can just ignore the bases. 3a plus 1 equals 2. Solve for a. Subtract 1, subtract 1. 3a equals 1. A equals 1/3. Everybody see how I'm getting 1/3? Right? You're dividing both sides by 3.
I have a question, Vaughn.
Go ahead.
So why is 9 like, why is it negative like the square?
Because I needed to write it with the same base. So I can't leave the 9 because I need to write it so the bases are the same. Once the bases are the same, then I ignore the bases.
Alright, thank you.
Was that adequate, Tyrese? Alright. Let's look at C. Ready for C? C, 625 to the 2n. Now, what I do, since they're not the same, I want to see if I can write 625 with an exponent on 25. So I go over here, and first thing I try is just the second power. It's 25 to the second power. And it's exactly 625. So that means I can rewrite 625 as 25 to the second power. And I'll leave the 2n on the outside. And I'm going to write a 1 on the 25 for emphasis. Right? Remember, if you don't see an exponent, the exponent is 1. It's that invisible 1. Now, what happens to the 2 and the 2n up here?
They add.
They multiply.
Oh.
So it'll be 2 times 2 is 4, so it's 4n.
Oh.
Okay, so now they're both written in the base with the exponent form. So that means you can ignore the bases and just look at the exponents. So what's the answer?
1 over 4.
1 over 4. Final answer, 1 over 4.
So what's the situation where nothing is there is 0?
Nothing is there is 0.
Yeah, like yesterday.
Oh, when it's addition or subtraction. We need something being added or subtracted, and there's nothing there, then it's 0.
So yesterday it wasn't the negative exponent that made it 0.
Like yesterday, you had equations like this, like 2 to the x, and you had a 3 times 2 to the x, like that. And then I asked for what's the horizontal asymptote, and the horizontal asymptote uses the plus whatever. Right? But there's nothing being added, that's a 0. Okay, this has nothing to do with today's lesson. I'm just answering somebody else's question.
Are you okay with that?
That's for the video. Alright. D. D. So here, can you write 81 as a power of 9? Yeah. What's 81? 9 to the what power? 9 to the second power. So it's 9 to the second power, x equals 9, so I'm going to write this without the fraction. How do I write this without the fraction?
1.
You're close. Negative 1. That's right. So if you have a 9 to the positive 1 in denominator, it becomes 9 to the negative 1 without the fraction. Okay? So here, that becomes 9 to the 2x equals 9 to the negative 1. So 2x equals negative 1. Divide by 2, and you get negative 1/2. All right, ready for E? E. Okay. Can you write 16 as a power of 4?
Yes.
4 to the second. So 4 to the second to the 2p minus 2 equals 4 to the what power? Negative 1. Okay, so make sure you multiply this out first before you rewrite it. So it's 2 times that. So it's 4p minus 4. I am distributing that 2 onto both of these. Right? 2 times 2p is 4p. 2 times minus 2 is minus 4. Alright, now they have the same base. I can just ignore the bases and just look at the exponents. Add 4, add 4. I get 4p equals 3. So p equals 3/4.
Are most of these going to be fractions?
Yes.
That's not a question.
Ready? Alright, F. Let's look at F. So this time I have 2 numbers over here. Remember 625 was 25 squared. So I'm going to do 25 to the negative. So I'm doing nothing with the first one. I'm writing 625 as 25 squared with a negative 2a on the outside. And I'm copying the right-hand side and writing the exponent of 1 for emphasis. Okay. By the way, with a lot of these, if you skip some of these steps, great! Do it. Skip some of these steps. I find all these steps annoying. Alright. So 2 times negative 2a is negative 4a. Okay. Now, what do I do with the exponents? By the way, I'm writing every step on this one because there's something new about this one. Alright? What do I do with the exponents when I have them like this? You add the exponents. So that's going to be negative 2a plus negative 4a, making it negative 6a. You add the exponents. Now, I'm going to, now they have the same base, 1 on each side, I'm going to ignore the bases and just write the exponents. So what's a equal to? Negative 1/6. Thank you. Ready? Only 4 more examples. Huh?
Could you do this in 25?
You mean right? Talking about what?
No, at the start of it.
Up here? Could I have written it as 5 squared?
At the start of it. Because you squared 25.
Uh-huh.
Could you do it to the other 25 though?
Like that, but
In the
like,
starting of it, the beginning of the whole problem?
The first
5 squared?
I don't understand the question.
You put 5 squared?
Use 5 squared instead?
Could you, yeah.
So if I use 5 squared, I'd have to write 25 as 5 squared and 625 as 5 to the 4th. Right, 625 is 5 to the 4th. Okay? So yes, I could use base 5. Was that your question? Can I use a different base?
No, I was like wondering why you want to do that. Like,
Oh, I always just use whatever the numbers are there. But you are welcome to use the smallest base if you want to. Okay? That is perfectly fine. In fact, so G, the smallest base is 2, but I want to use 4. But if you want to use 2, that is perfectly legit. Okay? And if you want me to do it both ways, I can. Alright, so now, so I look at this and I go, can I write 64 as a power of 16? Can I write 64 as a power of 16? Okay. But I want to do integer exponents, okay? So I'm going to just write, so 16 to the second power. What's 16 to the second power? Well, it's not 64, it's 256. So that means I don't want to use 16 as my base. Can I write 16 as a base with an exponent of a smaller number than 16? What can I write 16 as a base with an exponent?
Negative.
Let's use a positive number. 4 squared, right? 4 squared is 16. Now, we know 4 squared is 16, so let's see what 4 to the third power is. 4 to the third power is 64. And look, our other numbers we have here are 64. So I can use 4 as my base. Okay? So that will be 4 to the third raised to the b. And the 16, I'm going to write it as 4 to the negative 2. Remember 16 was 4 squared, but because it's a fraction, I'm putting a negative number in the exponent and writing it without the fraction. And then 64 is 4 to the third again, but don't forget the b plus 1 as the other exponent.
Where are you getting 6 and negative 2?
Okay, that's a b from that b.
Oh Lord.
Okay, I completely understand. It's hard to see. It's a negative because I had a fraction to begin with, and it's 2 because 4 squared is 16.
Okay.
And now, see, they're all the same base. They all have a base of 4. But I still got to combine these over here on the left side. So that's going to be 4 to the 3b times 4 to the negative 2. I'm going to go ahead and distribute these over here. So that'll be 3b plus 3. I did 3 times b gives me 3b. 3 times 1 gives me 3. Now, what do I do when I have bases the same and the exponents? What do I do with those exponents? You add them. So it's 4 to the 3b plus a negative 2. So I'm just going to write minus 2. Alright, so now what I have is 4 to the 3b minus 2 and 4 to the 3b plus 3. So I can write it, just the exponents. Right? Once the bases are the same, I can rewrite it with just the exponents. Now, how do I solve this? Right? You want to move the 3b at least away from the right-hand side. When I do that, what happens?
0.
They cancel. What I have is negative 2 equals 3. On what day of the week is negative 2 equal to 3?
Never.
Never. Therefore, you have no solution. When the variables disappear and you have a false statement, it is no solution. When the variables disappear and it's a false statement, you have no solution. What's your question?
If it's a true
Is
statement.
there a way, like, you can tell if there's no solution without doing anything? No?
No, not these.
What you looking at there like?
Alright. Now, the question is, what if it's a true statement? Then it's all real numbers. Okay? If you have a simple equation like this, and you end up with a true statement, then it's all real numbers. Alright, let's look at H. Looking at H. So recall, 625 was 25 to the second power. So all I'm doing right now is rewriting. Okay, so that's a negative a. I know it's hard to tell what that is. I just copied that negative a that was up here. And the screen is frozen. There we go. Alright. So I wrote negative a, that's the same negative a up there. Okay? Alright, so that becomes 25 to the negative 2a over 25 to the 3 minus 2a. I'm still just copying the denominator.
What just happened?
Huh?
How'd you got the 425 in the top?
The 425?
Yeah, cause like.
So the 625 turned into 25 to the second power. Do you remember that from previous problems? 625 is 25 squared.
Yeah.
And so 625 is still 25 squared. The denominator, I just copied. It was already a base of 25.
Oh, alright.
So I didn't do anything with the bottom.
Thanks, thank you, man.
Alright, now, what do I do with these exponents when it's division? Subtract, that's right. So I'm going to do negative 2a minus, so I'm going to write that out over here. It's negative 2a, that's the top exponent, minus 3 minus 2a, that's the bottom exponent. And that's going to equal 25 to the second power.
Hold on, what?
All I did was write negative 2a, the top exponent, minus the bottom exponent.
Where would the 3 go? Where would the 3 go?
It's right there in the parentheses. Minus parentheses 3 minus 2a. I am subtracting the bottom exponent from the top exponent.
Why won't that just cancel out?
What cancel out?
The 25.
The 25s do not cancel. You have to look at the exponents. But I'm writing it with only one 25, right? Just the 25.
Oh, that's how you got to.
Okay? Things only cancel when they're identical. Like, you have to have the same exponent as well.
Okay.
Because a plus negative 2a should be 0.
Right? So what am I left with?
Negative 3.
Negative 3. So that's 25 to the negative 3 equal to 25 to the second power. Right?
Okay.
That's right, Tyrese. The negative 2a's canceled.
How's that making a 25? I'll make it like 25, squared.
Right? The 25 squared comes from the 625.
But like, I'm asking like, how's a negative 3 making that though?
Is it? Can it? So here, the bases are the same. Now I can just look at the exponents. Is negative 3 equal to 2? No. So it's no solution.
Oh, that's why it made no sense. Okay.
Exactly. If it makes no sense, it is no solution.
What about for
Oh yeah, I'm
question
first
2?
anyway.
It says 3 minus and then exponent.
What can, or
It's 3.
how do you write 1
This,
as a power?
this could be a solution.
Let me do these problems and then I'll answer your question.
It's to the 0.
What to the 0?
3 is.
There you go. Alright, I'm looking at I. I'm looking at I. Now, the bases are already the same. The bases are already the same. So that means I can set the exponents equal to each other. How do I solve that?
M equals 2.
Does m equal 2?
Huh? Oh,
It's no
never
solution.
mind.
Yeah,
M equals
subtract
2.
the m from both sides. You get negative 1 equals 3.
Oh.
They're not the same. So it's another no solution problem. That's only 3.
Wait, what did it be? Oh,
Guess what? A lot of things in life have no solution. Hint, hint. Okay, last problem. Go ahead. Okay, if I add the 1, what I will get is 0 equals 4. It's still no solution.
Faith has the question.
Yes.
I
Okay. Alright. Do you want it recorded?
don't care.
Okay. Alright, so can I write 343 as a power of 49?
Yeah.
Okay.
30.
Alright. Andy says I can rewrite that. So let's do 49 to the second power. It's 2,401. Well, 49 to the first power is 49. So what power can I use? A really ugly power. So we're not going to do that. Okay? So what's better is, can I write 49 as a power of something? What? I can write 7 squared. That's 49. So the next question is, can I write, what's 7 to the third? 343. That's the number we have. So we're going to write 343 as a power of 7. And 49 as a power of 7. Multiply those exponents. I got 7 to the 6a equals 7 to the 6a.
You put a 2 right there.
2 where? Here
Oh no, there's
or here?
Wouldn't that be just zero?
Shouldn't that be a 3 right there? It's supposed to be.
If you did zero, no, no.
Because 7 to the second power is 49.
Oh, what I'm doing?
And then 7 to the third.
Yeah.
So does 8
It's
I know,
perfectly understandable. I made several mistakes
does 8
here.
equal 0
Alright, so I'm going to rewrite this
That is how he talks though.
without the exponents. And if, generally speaking, when you solve this, you don't divide by 6, you subtract the 6a, right? What do you get when you subtract the 6a? You get 0 equals 0. That's a true statement.
So could you have
All real
But
numbers.
could you have just looked at like the
Hold
7
on.
to the
Why are we all real
6A
numbers?
or whatever?
Why
and
does it equal zero?
said it was.
No.
It's 0 equals 0. It's not 1 equals 0. And yes, if you were here, you can decide here it's all real numbers. Because if the left side is perfectly identical to the right side, then A doesn't matter.
Right.
Okay?
Or you
Wait,
can
so
say
if
two
it's equal
problems,
to each
so,
other,
yeah.
like in any other equation, does that mean that these are all real numbers?
Yes. But they have to be completely identical, right? It can't just be kind of like, it has to be completely identical. So if I had a problem like x squared plus 2 equals x squared plus 2,
You want to know something?
that's completely identical. You can say it's all real numbers.
My boy changed that.
Okay? All right. So that's it. That's the end of the lesson. I am stopping the recording.